This video is about mathematical induction. The principle of mathematical induction. Let P sub n be a statement about natural number n. Then P sub n is true for all natural number n if and only if P sub 1 is true for every natural number k. If P sub k is true, then P sub k plus 1 is true. Cap for math induction proof. Check. The statement is true for n equals 1. Assume the statement is true for n equals k. Prove the statement is true for n equals k plus 1. Then we can draw a conclusion. The statement is true for all natural number n. Use mathematical induction to prove that each conjecture is true for all positive integers n. Question 3. 2 plus 2 squared plus 2 to the third power plus 2 to the nth power equals 2 times 2 to the nth power minus 1. We will use the cap method. Check, assume, prove. Check is true for n equals 1. For the left side, we got the first term, 2, equals. On the right side, 2 times 2 to the first power minus 1, both equal to each other. Assume it's true for n equals k. 2 plus 2 squared plus and 2 plus 2 to the kth power equals 2 times 2 to the kth power minus 1. Basically change every single n into k. Prove it's true for n equals k plus 1. You can check this one. On the left side, you need to add k plus 1's term. 2 plus 2 squared plus 2 to the kth power plus 2 to the k plus 1's power equals 2 times 2 to the k plus 1th power minus 1. We will start with the left side. Equals. Use the assumption. The first k terms equals this. Do the substitution. 2 times 2 to the kth power minus 1 plus 2 to the power of k plus 1. Then always check on the right side. We have 2 as a common factor. So you need to take a common factor 2 if possible. We do know 2 to the power of k plus 1 equals 2 to the kth power times 2 to the first power. In this way, we can create 2 as a common factor. Now I take a 2 out. 2 to the kth power minus 1. Then plus 2 to the kth power. 2 to the kth power plus 2 to the kth power equals 2 times 2 to the kth power equals 2 to the power of k plus 1. So we got 2 times 2 to the power of k plus 1 minus 1. This equals right hand side. So 2 plus 2 squared plus 2 to the nth power equals 2 times 2 to the nth power minus 1. For n is all natural numbers. Question 6. Check is true for n equals 1 on the left side. The first term is 1 equals 1 squared times 1 plus 1 squared over 4 equals 4 over 4. It's true for n equals 1. Assume it's true for n equals k. 1 plus 8 plus 27 plus. Change n into k to the third power equals. On the right side, change every single n into k squared times k plus 1 squared over 4. Proof is true for n equals k plus 1. 1 plus 8 plus 27 plus k to the third power. Then you need to add k plus 1th term, which is k plus 1 to the third power equals. On the right side, change every single k into k plus 1. K plus 1 squared times k plus 1 plus 1 squared over 4. Simplify the right side. K plus 1 squared times k plus 2 squared all over 4. Let's start with the left-hand side equals. Use this assumption. The first k terms equals this. So we do the substitution. K squared times k plus 1 squared over 4 plus k plus 1 to the third power. Since we have a fraction, we will get the same denominator. Do not rush to expand k plus 1 squared or k plus 1 to the third power because there is a common factor k plus 1 squared. K squared times k plus 1 squared plus 4 times k plus 1 to the third power over 4 equals k plus 1 squared is the common factor, so we take k plus 1 squared out. We got k squared plus 4 times k plus 1. Then simplify. K plus 1 squared times k squared plus 4k plus 4. Factor k plus 1 squared times k plus 2 squared over 4 equals right hand side. So 1 plus 8 plus 27 plus n to the third power equals n squared times n plus 1 squared over 4. For n is all natural numbers. Question 7. Check is true for n equals 1. The first term on the left side is 1 squared equals 1 equals 1 times 2 minus 1 times 2 times 1 plus 1 is 3 over 3 equals 3 over 3. It's true for n equals 1. Assume it's true for n equals k. 1 squared plus 3 squared plus 2k minus 1 squared. Just change every single n into k. K times 2k minus 1 times 2k plus 1 all over 3. Proof is true for n equals k plus 1. We need to add k plus 1th term on the left side plus 2k minus 1 squared plus 2 times k plus 1 minus 1 squared. On the right side, we need to change k into k plus 1. K plus 1 times 2 times k plus 1 minus 1 times 2 times k plus 1 plus 1 all over 3. Simplify this right side. K plus 1 times 2k plus 2 minus 1 is 2k plus 1. 2k plus 2 plus 1 is 2k plus 3, all over 3. Left-hand side equals the first k terms equals this based on the assumption. So we get k times 2k minus 1 times 2k plus 1 over 3 plus distributive property 2k plus 2 minus 1 is 2k plus 1 squared. Make the same denominator. Do not rush to expand because we have a common factor 2k plus 1 equals 3. We will take 2k plus 1 out. Then do the distributive property here, 2k squared minus k plus 3 times 2k plus 1 equals 2k plus 1 times distributive property here, 2k squared minus k plus 6k plus 3 over 3 equals, keep simplifying, 2k plus 1 times 2k squared plus 5k plus 3 over 3. Need to ask to factor this trinomial 6, 5 over 2 over 2, 2, 3. Reduce 1, 1. So we have k plus 1 times 2k plus 3. 2k plus 1 times k plus 1 times 2k plus 3 equals right hand side. So 1 squared plus 3 squared plus 2n minus 1 squared equals n times 2n minus 1 times 2n plus 1 all over 3. For n is a natural numbers. Go to question 10. Check is true for n equals 1. On the left side, the first term is 1 over 1 times 2 equals 1 over 2 equals, change n into 1 on the right side, 1 over 1 plus 1. It's true for n equals 1. Assume it's true for n equals k. Change every single n into k. 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over k times k plus 1 equals k over k plus 1. Proof is true for n equals k plus 1. We just need to add k plus 1th term on the left side, and then change every single k into k plus 1 on the right side. 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over k times k plus 1 plus 1 over k plus 1 times k plus 1 plus 1 equals, change every single k into k plus 1 on the right side. K plus 1 over k plus 1 plus 1. Simplify the right side. K plus 1 over k plus 2. Left hand side equals, use assumption. The first k terms equals this. K over k plus 1 plus 1 over k plus 1 times k plus 2. So we need to make the same denominator on both denominator and numerator times k plus 2. So we get k plus 1 times k plus 2 as a denominator. Distributive property, k squared plus 2k plus 1. The numerator, we got k plus 1 squared. Denominator, k plus 1 times k plus 2. Reduce, we got k plus 1 over k plus 2 equals right hand side. So 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over n times n plus 1 equals n over n plus 1. For n is all natural numbers.